talk about a few example questions, a few practice questions that we did on the equations of motion. Okay, so uh, the first question over here is a car increases its speed from 25 meters per second to 31 meters per second. So its initial speed is 25 meters per second. Final speed is 31 meters per second with a uniform acceleration. This is a keyword. Since the acceleration is uniform, this means that acceleration is constant, right? Acceleration is constant. Constant acceleration basically means that the equations of motions can be applicable because this is a uniformly accelerated motion. Now, acceleration is 1.8 meters per second squared. How far does it travel? How far does it travel while accelerating? Now let's first gather the data that we are given. The initial velocity u is given as 25 meters per second. Final velocity v is given as 31 meters per second. The constant acceleration is given as 1.8 meters per second squared. And s, the distance is asked. So equation of motion that is applicable. Okay, time is not given. So the only equation of motion that does not involve time is v squared equal to u squared plus 2as. Rearrange it to find s. S is the displacement. So s is equal to v squared minus u squared upon 2a. V squared, the final velocity is 31 squared minus the initial velocity 25 squared upon twice of 1.8, and whatever answer that we get will be our answer in meters. Okay, now let's go to the second question. The okay, the average acceleration of a sprinter, the average acceleration, okay, so again the acceleration is constant, it has an average value of a sprinter from the time of leaving the blocks. So the sprinter left the block, so this means that initially it was at rest, the sprinter was at rest, so initial velocity was 0 to reach her maximum speed of 9 meters per second squared. The final velocity is given to be 9 meters per second. Sorry, not meters per second squared, it's meters per second, 9 meters per second. And acceleration, the average acceleration is given as 6 meters per second squared. For how long does she accelerate? For how long does she accelerate, meaning the time of the acceleration, and what distance does she cover in this time, and the distance is also asked. Both the things are asked and the data is given. Let's first gather our data. Initial velocity is 0, final velocity is 9, acceleration is 6, time and distance are asked. Okay, so let's use an equation of motion that can give us the value of time and does not involve s. So the equation of motion that does not involve s is v is equal to u plus at. Rearrange it to find t. T is equals to v minus u upon a. V is 9 minus u is 0 upon a is 6. So it becomes 3 upon 2, which is 1.5 seconds. Okay, 1.5 seconds is our time. Now let's find the distance through which she has traveled, the distance that she has traveled. So we have the time, we have the acceleration, initial and final velocities. We can just use the formula s is equal to ut. S is equal to ut plus half at squared. U is 0. U is 0. We don't need v, we just need the acceleration and the time that we calculated. Half times a is 6 and t is 1.5, 1.5 squared, and the answer that we get written over here. Now let's go to the third question. A cricketer throws a ball vertically upwards. Okay, upwards into the air with an initial velocity of 18 meters per second. Okay, so we how high does the ball go? So basically the vertical height is asked, and how long is it before it returns to the cricketer's hand. So basically the total time is asked. The total time is asked. How long is it before it returns to the cricketer's hand? So basically the time of going up and coming down, both are asked. So let's make a small picture over here of the ball being going up. Ball goes up, its initial velocity was 18 meters per second. It reaches a maximum height, then it returns back to the same person. So before hitting his hand, its velocity must have been 18 meters per second as well. Its speed actually 18 meters per second. Okay, now we need to find this as the height, the vertical height. Basically, this entire height is asked, and the time of both going up and down is asked. Okay, now how to find s? We know that over here its velocity was 0 because the ball is momentarily at rest. Just before hitting the person's hand, his velocity the ball's velocity became 18 meters per second. So we can use an equation of motion. We know that the acceleration is fixed for free falling motion, 9.81 meters per second squared. So we can just use the formula S is equal to ut plus half at squared. Oh no, we can't use this because we don't have time. My bad. We don't have the value of time. But we can use the formula v squared equals u squared plus 2as. Okay, now the final velocity in this case is 18 meters per second. Initial velocity is 0. Acceleration is 9.81. And s is asked. Okay, so final velocity is 0. Initial velocity is 18 squared plus twice of acceleration is going to be 9.81. And oh, actually, wait, I did small mistake over here. The final velocity in this case is 18 meters per second. If we take the balls upward over here, this velocity to be the initial velocity and this velocity to be the final velocity, the final velocity is 18 squared. Initial velocity is going to be 0 if we are assuming that the ball is dropped over here, right? This is just like the motion of dropping a ball in free fall. And the acceleration is positive 9.81 because the ball is going downward and its velocity is increasing, and s is to be calculated. So s is equals to 18 squared divided by twice into 9.81. Whatever the answer that we get is going to be the height. Then we are asked to find the time. How long does it is it before it returns to the cricketer's hands? Okay, so basically to find the time, what we need to do is find the time of either of the two parts. This journey of the ball is in two parts. One is going upwards and the other is coming downwards. So if we find the time of either of the two parts and multiply it by 2, we'll get the total time. Okay, so now let's find the time of the ball coming from upwards to downwards. Okay, if we take again the initial velocity to be 0, we take the downward motion. We are considering the downward motion. The initial velocity to be 0, the upward over here, the velocity over here is 0. The final velocity to be 18 meters per second. Time is not known, right? We need to find the time. And the height that we just calculated over here, okay, wait, I'll calculate the value. 18 squared upon 2 into 9.81. This is 16.5 meters. Okay, we know the distance is 16.5. We can find the time by using the formula S is equal to ut plus half at squared. S is 16.5, u is 0, half times acceleration is 9.81, and t squared, t is to be calculated. Rearrange this equation, this expression times 2 upon 9.81 and take square root you'll get the time. Here is 1.83 meters per 1.83 seconds, and this time is for a single part of the journey, for the ball coming downwards from the maximum height to the surface. Okay, an equal amount of time would have been consumed for the ball to reach the maximum height as well. So the time taken for the ball to reach the maximum height and then return to the cricketer's hand is gonna be 1.83 multiplied by 2, and so the total time that we'll get is gonna be 3.67 seconds total time.